let's review the definition of atomic number, mass number, isotopes, and ions. The atomic number is the number of protons which are found in the nucleus of the atom. So let's just do a little review. In the center of the atom, you have your protons and your neutrons. The protons are positively charged, the neutrons do not have any charge. And then in shells that surround the atom, you do have the electrons, which are smaller in size but negatively charged. The atomic number is talking about the number of positively charged protons that we find in the nucleus of any given atom, and the number of protons actually helps us determine the identity of the atom. For example, only hydrogen atoms have one proton in the nucleus, and only helium atoms will have two protons in the nucleus. So the atom's identity is usually determined by the number of protons. And then we also have the mass number. The mass number is the sum of protons and neutrons that are found in the center of the nucleus. The reason why the mass number is looking at only the protons and the neutrons is because the electrons are really small in size, so they're not really that heavy. Most of the mass of the atom is localized in the center of the atom in the place called the nucleus. So when we're trying to determine the mass number, we look at the number of protons as well as the number of neutrons that are found in the nucleus of the atom. That means that if we want to calculate the number of neutrons only, then we're able to just subtract the mass number from the number of protons, and then we can easily solve for the number of neutrons. Here's an example. I have neon. 20 at the top, which is the mass number, 10 at the bottom, which is the proton number or the atomic number. If I want to find out the number of neutrons, then I just have to do 20 minus 10. That means that I have 10 neutrons in this neon atom. And then if we want to look at the definition of isotopes, isotopes are when the atoms have the same number of protons. So this means that it's the same atomic identity, because remember, the atom's identity is only looking at the number of protons. However, they have different numbers of neutrons. So that means that they have varying masses. So one mass is heavier than the other mass because the number of neutrons is different. So here's an example, carbon. Carbon is when the protons have 6, or when the protons are 6 in number, sorry. And so you can have carbon 12, carbon 13, or carbon 14. In carbon 12, you only have 6 neutrons. In carbon 13, you have 7 neutrons. In carbon 14, you have 8 neutrons. So because of that, carbon 14 is heavier than carbon 12, but it's still carbon because the number of protons still remains 6. So the mass number is different. And this is actually very natural. Like, it's very natural for certain atoms or elements to exist in different proportions of isotopes. For example, majority of the carbon that we find in nature is carbon 12, about 98%, and it's stable. But we still have carbon 13, about 1% is carbon 13. And then we have carbon 14, which is a radioactive amount, or a radioactive version of carbon, but it's still carbon. So it's very natural to see different isotopes existing in different amounts in nature. Some isotopes are more stable than other isotopes. And then you have your ions. This is the situation where, again, the number of protons is the same. So the atomic identity is the same, and the number of neutrons is also the same. However, the number of electrons that you find in the atomic shells surrounding the nucleus of the atom is different. So naturally, you will have the neutral version of an element. So I have X, which is neutral. And then let's say that this element, or sorry, this atom wants to lose one electron from its shells. Then it gets a positive charge and it becomes a cation, which is a positively charged ion. Or if I have a neutral X atom, and it wants to gain an electron, then it adopts a negative charge. So it becomes an ion, or an anion, which is a negatively charged version of the atom. So you have your atoms which are neutral, and then if the atom adopts a charge, whether it's positive or negative, or whether it's 2 plus or 2 minus, 3 plus or 3 minus, then it becomes an ion. Okay, so I have this example of sodium. Sodium has the symbol of Na, and if sodium loses one electron from its outermost shell, So this electron goes out. Then it goes from having 3 shells to 2 electron shells. And because it lost that electron, it got positive by 1. Because remember, electrons are negative. We even write the symbol of electrons as E minus. So if you lose 1 electron, you lose 1 negative thing and you become positive. If I lose 2 electrons, then I have a 2 plus charge. If I lose 3 electrons, I have a 3 plus charge. And so because of that, sodium went from being neutral, no charge at all, to losing an electron on the product side, and then sodium became positively charged by 1. You also have instances where the atom will gain 2 extra or 2 or more or even 1 electron. If it's gaining an electron, then it's becoming negatively charged. For example, if I have oxygen, and then the oxygen maybe wants to gain 2 electrons, so 2e minus, then it becomes an oxygen ion or an ion. So it has an O2 minus charge. So these are examples of ions. In ions, there's charges. In isotopes, you have varying masses due to different number of neutrons. And then we've reviewed what the atomic number is and what the mass number is. Please like and subscribe and follow, comment for more. Thank you so much, and I'll see you in the next one.